Section 2.7, Inverse Functions. In the last lesson, we learned how to find the composition of functions, and we will be using that again here in 2.7. So if you look at the first sentence on this slide, it says, if f of g of x equals x and g of f of x equals x. So in the last lesson, we used that circle notation. So this is the same thing as f composition g of x. And this is g composition f of x. So if we were to find both of those compositions and get x as the answer, then g is the inverse function of f. And we would denote the inverse using this symbol, f, and it looks like an exponent because it's superscript. You'd have a -1 up next to the f. You actually wouldn't read it as an exponent. When you read it, you would say f inverse. That's what it means. It does not mean f to the -1 power. So if this happens, they both turn out to be x, we can say that f and g are inverse functions of each other. So let's practice that concept with these problems. It says find f of g of x and g of f of x and determine whether each pair of functions f and g are inverses of each other. Okay, so let's focus on this first. Find f of g of x. The functions are given here. This is exactly what we did in 2.6, except we started out with the notation that had the little circle for composition. So f of g of x, we know that means f of, now we're going to substitute g of x in the parentheses, 4x plus 9. And that, of course, is telling us, go look at f, and in place of the x, which is right up here on the top, that x is going to come out, and 4x plus 9 is going to go in its spot. And then after we replace the x, we still need the -9, and we need the 4 on bottom. Now, since we just have a 1 in front of our parentheses, we can go ahead and combine like terms on top. Distributing the 1 would just give 4x plus 9 right back. So I'm going to go ahead then and combine like terms. 9 minus 9 is 0. So now on top, I would just have 4x. And I would still have the 4 on bottom. And then the last step, I'm going to divide 4 by 4, which is 1. And 1x, of course, is x. Now, just because we got x here doesn't necessarily mean that they are inverses yet. We still have to find g of f of x. So we keep the g. In place of the parentheses there, we're putting what f of x is. So that's x minus 9 over 4. Okay, so look at g now. And g starts with a 4, so we need that 4. Then we're replacing the x with this fraction, x minus 9 over 4, and then a plus 9. So this looks like g, except the x has been replaced with what we have in the parentheses. Now when you simplify these, make sure you simplify correctly and show all the work. If you skip steps and just go to the end and say equals x, you will not get credit. So order of operations, I would multiply first. So when I multiply these, I'm allowed to divide out the 4s. 4 into 4 goes once. And 1 times x minus 9 is x minus 9. Bring down the plus 9. And then combine -9 plus 9, which is 0. So we do end up getting x. So we got x for f of g and x for g of f. If they both equal x, then we can answer the question. So we did this part. Now determine whether each pair are inverses. Since they both equal x, then we would say yes. meaning yes, these functions are inverses of each other. Let's try another one. Same instructions. So we're going to start by finding f of g of x. So that's f of, and then we're putting x cubed plus 4 inside in place of g. And now just focus on this step right here. It's telling me to look at f, and when I look at f, I see a radical, a cube root, so I need to write that down. And inside the radical, I have x first. That's where I'm going to place my x cubed plus 4. All of that is in place of this x. And now I still need a minus 4 under the radical. Okay, so here again, like on number 1, I've got parentheses, but I've just got a 1 in front. So if I distribute the 1, I would just get this same expression back, which means I can go ahead and combine like terms. And I can do 4 minus 4 is 0. So then I would just have an x cubed under the radical. And the cube root of x cubed is x. Remember, when the root and the exponent are the same, they kind of cancel each other out, and you would just get the x. Okay, let's try g of f of x. So that would be g of the cube root of x minus 4. All right, so look at function g. It starts right away with x, so that's where we put our radical. Cube root of x minus 4. All of that goes in place of the x. That's going to be cubed, and then we need a plus 4. To simplify, we have a cube root and a cube, and so those are going to get rid of each other and leave just the x minus 4. Bring down the plus 4. Now combine like terms, and we do get x. So this again, the answer is yes, these functions are inverses. Now it doesn't always turn out that way. A lot of times it does, okay? But you can't just assume it's x. You have to go through the work and go through the correct steps in order to get the answer when you do the composition. Okay. So the next type of problem we're going to do is actually finding the inverse function. In those first two examples, we were given both functions. But now we're only going to be given one function, and then we will find the inverse function. So the steps are listed on this slide. It says step 1, replace f of x with y. Step 2, interchange x and y. Step 3, solve for y. And notice it says, if this equation is not a function, then there is no inverse. So not every function does have an inverse. However, on the problems that I give you that ask you to find an inverse, there will be one. I'm not going to try to trick you with that. And step 4, replace y with f inverse of x. This is that notation we saw on the first slide. So at the end, you're going to use this notation, which is just really naming it as the inverse. Okay, let's try this on some examples. Number 1, instructions say, find an equation for f inverse. The function given here is a linear function. We'll look at a few different types. So let's just go through the steps. Step 1, replace f of x with y. Step 2, interchange x and y. So now where it says y, I'm going to write x, and where it says x, I'm going to write y. Step 3, solve for y. So if I'm trying to get this y term by itself, I need to go ahead and subtract the 5. So on the left side, that would be x minus 5. And now I can get y by itself by dividing both sides by 3. So I have x minus 5 over 3 equals y. And you can leave it in this form. That's fine with me. Of course, you could also divide the 3 into each term on top, which would then look like x over 3 minus 5 over 3. And really there's a 1 there, so you might even choose to write it as 1/3 x minus 5/3. Those are all okay, but I really would just leave it right like this for this type of problem. And the last step is to replace the y with the notation f inverse of x. And that would be our answer. So we certainly could check our answer. Let's go ahead and check this one just so you can kind of see that at least once. We saw at the beginning of the lesson that when you have functions that are inverses, when you do the composition both directions, you should get x. So let's try that here. This is going to be our check. I'm going to start with f of f inverse. So that's going to be f of x minus 5 over 3, the answer we got here. So then when we go, let's kind of separate this. When we go to f, we've got a 3, and then we're replacing x with x minus 5 over 3 and a plus 5. So to simplify that, we divide out the 3's, 1 times x minus 5, and bring down the plus 5. Combine like terms, and we do get x. So far, so good. Okay, that's what we need to get. And then the next step would be, okay, try it the other way. F inverse of f. So that'd be f inverse of 3x plus 5. So we're going to look down here. This is our inverse function that we boxed in at the bottom here. And in place of the x, we're putting 3x plus 5. And then we have a minus 5 next to that. And on bottom, a 3. So to simplify on top, I can go ahead and combine like terms. Plus 5 minus 5 would be 0. And then I could divide out the 3's. And I get x that direction as well, which is good. Since I got x both ways, then I can say, okay, yes, this works. This must be the correct inverse function. Okay, let's try another one. I'm going to go back to our 4 steps. Step 1, replace f of x with y. This problem's a little different. It's the same steps, but our function is a cubic function this time. It's not linear. Okay, we're still replacing f of x with y. That was step 1. Step 2, interchange x and y. So it'll be x equals y cubed minus 1. Step 3, step 3, solve for y. So now we're trying to get this y by itself. Let's first of all add the 1. So now we've got x plus 1. And then we're trying to get y by itself. Now this is y cubed. So you can't just divide to get y by itself. If it's cubed and you want it not to be, then you would have to take the cube root of both sides. So I'm going to just write that on the next step. I'm going to take the cube root of x plus 1. I'm going to take the cube root of y cubed. Now this, on the left side, does not simplify. But on the right side, a cube root of y cubed is just y. And that's what we wanted. Now we have the y by itself. The last step again was replace y with f inverse of x. So this is our inverse function. And of course you could go through the check again by finding the composition f of f inverse and f inverse of f should both be x. I'm not going to work out the check this time, but feel free to do that on your own time. And we're going to look at one more example of finding the inverse function. This time we're starting out with what's called a rational function. It's a fraction with variables in it. So it's still the same 4 steps. We replace f of x with y. Next step, interchange x and y. So this y on the left is now an x, and both of these x's on the right will become y's. Step 3, solve for y. Now, that's where this one gets a little more challenging than the first 2 examples. When you think about solving this equation, the first thought that we want to deal with is, well, we've got a fraction in our equation. And anytime we have a fraction, we want to go ahead and clear that out. So our denominator is y plus 2. That would be the LCD. So we're going to multiply by y plus 2 on the left side and on the right side. So when we multiply on the left side, we are going to distribute the x. So it would be x times y plus 2x. When you multiply variables, it's best to write them alphabetical. On the right side, we're going to cancel the y plus 2's. So now we have just a y minus 3 over there. Okay, so that was just to get rid of our fraction. Now we really need to be thinking about, okay, I'm trying to solve for y. Let's find y. Here we have a y on the left. We also have a y on the right. We need those y's to be on the same side of the equal sign. Doesn't really matter left or right, but I'm going to make them on the left. So I'm going to leave this xy on the left, and I'm going to subtract this y to move it over to the left. Now my other terms I want to be on the right side. So I'm going to move this positive 2x. So I'm moving it. It becomes a negative 2x. And the negative 3 just stays. It did not move sides. So let's make sure we understand what we're doing here. We want y's to be on the same side. So I subtracted this y to move it to the left. And the non-y terms over to the right. So I subtracted the 2x to move it to the right. Okay, so now we have both y terms on the left. We need to get just a single y in order to isolate it. And this is a step that you might not think of doing, but the way that we can get just one y out of this is to factor out the y. On the left side, both terms have y, so y would be the GCF. So you are going to factor out the y. When we divide those terms by y, we're going to get x minus 1. So we might make a note out here. I'm going to put it in a different color and to factor out the y, because that's a step that a lot of times students don't think of. Factor out y. Okay. So now to isolate the y, since it's multiplied by this whole thing, x minus 1, I'm going to divide by x minus 1. So now the y is by itself. And this fraction I have on the right side cannot simplify. It's just going to stay negative 2x minus 3 over x minus 1. Remember, I can't cancel because I've got the subtraction there. I can only cancel over multiplication. And then the last step is replace y with the notation f inverse of x. So this is our answer. This is our inverse function. When you get to this step here where you've solved for y, the other side of the equation cannot have any y's on it. Okay, if you ended up with a y somewhere in this answer, something went wrong. Okay, so make sure when you try the homework problems that you look back at these examples and follow these steps, learn them so that you can do them on the test. Okay, the next concept in this lesson is the horizontal line test. It says, if a horizontal line intersects the graph at more than one point, then the function does not have an inverse. So it's very similar to the vertical line test. Let's change colors here. We'll call it VLT for vertical line test. That test was used to determine if the graph was a function. Okay, is the graph a function? Now we're learning the horizontal line test, and it is used to determine if the graph has an inverse. Okay, but in both cases, if it intersects more than once, the answer is no. Okay, let's write that down. More than one intersection means no. Okay. All right, so we're going to practice this horizontal line test. It says, use the horizontal line test to determine if the graph has an inverse function. So on number 1, we just have the graph of a line. We are going to draw a horizontal line through the graph and see how many times it intersects. And so we see here there's only one intersection. Exactly one intersection means yes. Now what are we saying yes to? We're saying yes, this graph does have an inverse function. Look at number 2. If we draw a horizontal line to intersect the graph, it will intersect twice. So no, this graph, which is the quadratic function, does not have an inverse function. So again, it works very similar to the vertical line test. However, it's important that you know the difference in which test is used for determining a function and which test is used for determining an inverse. Okay, one more concept that we will look at in this lesson. I'm only doing one video for 2.7. And the next thing we're going to look at is the graphs of inverses. So let's read the sentences on this slide. If the point AB lies on the graph of F, then the point BA must lie on the graph of F inverse, and vice versa. So you have an ordered pair on your graph. If you switch the x and the y coordinates, then the point with the x and y switched will be on the graph of the inverse. And that should kind of make sense after we did those problems of finding the inverse function where we had to interchange x and y. So that's what's happening here. The x and the y are interchanging. And then look at the next sentence. The graphs are reflections of each other in the line y equals x. And that's just kind of an interesting fact, and you can use that to check that you have graphed your inverse correctly. So to graph the inverse, you're going to find points on the graph that's given. There will be one given graph. You will pick out some points on that graph and write the ordered pairs. Then second, interchange x and y for each ordered pair, graph the new points, and then you'll have the inverse graph. Let's try it. Okay, it says use the graph of F to draw the graph of its inverse. So this line that's given is F. I'm going to label that F. Go ahead and do that as well on your notes. This line is F. So out to the side here, we're going to write F, and we're going to list some ordered pairs that we can find on the graph of F. Now, you of course want to find points that are right at the intersection of the grid lines. So, for example, this would be a good point. That point is 0, 3. Remember, always give the x first. We could do this point right here. It's at the intersection of the grid lines is 1, 1. We could do this point here is 2, negative 1. And let's go ahead and do one more point. This last one is 3, negative 3. Okay, so now out to the side of that, we're going to write F inverse. And each ordered pair, we're going to switch x and y. So now we have 3, 0. When we switch 1, 1, it's still going to be 1, 1. Our third point will be negative 1, 2. And then the last one, negative 3, 3. So you switch the x and the y. You do not change any signs. Okay, do not change the signs. So now we're going to plot these points that we found here for F inverse. So we're going to plot 3, 0, 1, 1, negative 1, 2, and negative 3, 3. And if you have a straight edge, go ahead and use it to draw a line through those points beyond. Don't stop at the last points. Keep going beyond. And I will do the best I can to make that line straight here. Let me see if I can use a straight edge myself. Not sure how well this is going to work, but we'll try it here. Well, okay. And go ahead and put some arrows on the ends and label that F inverse. So that red line that I drew is F inverse. Okay, so that's how you graph it. Now remember the sentence that said these graphs will be reflections about the line y equals x. Y equals x. Well, the line y equals x is going to go through 1, 1, 2, 2, 3, 3, negative 1, so forth. Every point where y and x are the same. And so I'm just going to kind of dash that in there. You do not have to draw y equals x, but I'm drawing it just to kind of help you see that these are reflections about that line. If I folded this top part of F over that dashed line, it would lie on this part of F inverse, on the red. And then, of course, if I took the bottom part of F reflected over the dashed, it would be corresponding to F inverse on the left side here. Sometimes it's a little harder to notice that relationship, the reflection about y equals x, whenever they cross y equals x. But the next graph, it may be a little easier for you to see that relationship. So let's go ahead and do one more. All right, so we have a graph here. This is just a smooth curved graph. It's not a straight line. Name it F. And then we're going to pick some ordered pairs on F. And usually at least 4 is a good idea. So to get 4, we're going to go ahead and pick some that are right at the ends of the arrows. So I'm going to start down here at the bottom with 0, negative 4. And let's see where else I can pick. I can pick this point here. which is 1, 0. I can pick this point is 2, 1. And let's go to the end of the arrow there at 4, 2. So now we have 4 ordered pairs that are on F. Let's out to the side, let's write F inverse, and let's switch X and Y. So we would get negative 4, 0, 0, 1, 1, 2, and 2, 4. We're not changing any signs, we are only switching the X and the Y. So now let's plot those. We're going to plot negative 4, 0, 0, 1, 1, 2, and 2, 4. So you plot the points, and then you have to keep in mind that the shape of the graph will be the same as the shape of F. It's just going to be going in a different direction. So it's going to curve kind of like F did. Keep in mind it's reflecting about y equals x. Remember where y equals x is? It goes through the origin, right in the middle of the first and third quadrants. Okay, so let's try to draw this. We're going to curve through our points, and really we should go a little beyond and draw some arrows on the ends. And this is the graph of F inverse. Go ahead and label it. And then y equals x, remember, is the line of reflection. You're not required to graph it, but again, I want to go ahead and do that here. And go through 0, 0, 1, 1, 2, 2, so on. So we'll dash that in there. So y equals x. And this one's a little easier then to see. The F and F inverses, F is a reflection of F inverse about this line, y equals x. Okay, so that is the last type of problem we're going to do with inverse functions. And this is, again, the only video for 2.7, so you should be able to do all of the homework problems. Let me know if you have any questions.